There we go. Okay. So the other cool thing that you can do with measuring particle motion is that particle motion acceleration is a vector quantity. It's not a scalar quantity like pressure. And that means that it carries spatial information with it. So if you have 3 accelerometers that are that contain vector data, that means that you can calculate the azimuth, or the horizontal angle, and the elevation, or the vertical angle, at which a sound is produced. So from just the accelerometer data, we can actually triangulate where the whale is in relation to our sensor. So up here you have another spectrogram. You saw this view before. There's 3 gunshot calls over time. And if you plot the azimuth, or the horizontal angle at which the sound comes from, what you see is that most of the background sound over time is at an angle of about 10 degrees. All right, so that's just a little bit off of north. And then at the times where these vocalizations occur, the sound source direction changes. It then starts at about 30, 33 degrees. So from when we recorded these calls, the whale that was producing these was about, thank you, appreciate it, was about, I was politely ignoring it, but you can see that the whale that was producing these vocalizations was just a little bit north-northeast, so it was about 30 degrees away from us. The graph on the right shows the elevation, and you can't actually really see, there's no clear trend in the data. When these vocalizations occur, the intensity spots here, they correspond, they're pretty level with all the background noise, and that makes sense. That just tells us that the whale, when it was vocalizing, was pretty much horizontally oriented to our sensor. Okay, so to wrap up here, conclusions and discussion. So this data shows that right whales and humpbacks from the previous data do produce particle motion when they're vocalizing. In addition, particle motion contains cues for both the sound direction and the distance of the signaling animal. And we also know that it's highly likely, based on other studies, that mysticetes can probably hear particle motion and therefore detect these cues. So all this is kind of the handy, wavy moment of my presentations where I say, oh, hey, I found something. This all suggests that particle motion very well may be a communication pathway in mysticetes that really has been overlooked. So for the past 50 years when they study acoustics with mysticetes, they're always looking at the pressure component. This suggests that this might be something else that we should really try and look at further. So the next steps for future research are, what about additional species? And it's very highly likely that other species do produce particle motion when they vocalize. We're hopefully going to be collecting data like this from blue whales in Scalfandi Bay in June. All this stuff, can we actually quantify what the biological function of the particle motion is? Like, how do they use it? But it's more easily asked than answered. Studying hearing and communication mysticetes is incredibly difficult. We don't exactly know under what context a lot of species use their vocalizations. So this is for the future, and we're working on ideas of how to answer these questions. And then what implications does this have for anthropogenic noise impacts? If mysticetes are using particle motion for communication, we need to investigate what amounts of particle motion other anthropogenic noise sources are kicking out into the environment. So we need to take measurements of commercial ships and wind farms and military sonar and things like that. And so far to date, there's no published data on the magnitudes of particle motion that are generated by these anthropogenic sources. Okay, so with that, thank you for your attention. I really appreciate it. And I guess we'll take questions after everyone. We want questions now or after everyone's done their presentations?
After the first 3.
After the first 3. All right, we'll take questions later. Sorry, Pablo. Thank you. Did you try this just out of curiosity?